Let's quickly start with the introduction first. So we'll understand what the release process is, where CICD fits in, where does AWS services like code source, build, deploy, and pipeline works, and how does that fits in with CICD. And then we'll look into quickly a demo of code build, deploy, and pipeline. So start with the release process. So any typical release process would have the 4 stages: source, build, test, and production. The source will comprise of a check-in of the code. So you have a check-in, you have a development code ready, and then you are checking into a source code. It could be a Git, it could be GitLab, your code source, and then you do a peer review. It's also a very critical part of the process. And once you have done that, your code is ready for the next stage, which is the code build, and where you will compile a code, and then you will do, you could do a style checking, you could do a syntax checking of your code. You can run some sort of unit test, an artifact build. There could be languages where you don't need a compiling of code, which is fine. Like Python, you don't need a compilation of code. So overall, you will make some sort of artifact at the end of the stage. It could be your image. If you are using a Docker image, you're building it and pushing it to a repository, or it could be an application image like a jar file or zip file which you're deploying to a machine or EC2 instance or cluster, and then using that as for the next stage. The next stage is the testing part, where you will be having some sort of test environment where you will be running an integration test, a load test. It could be a requirement for, if a UI heavy, a UI test, or a penetration testing you might even require. So once you have this whole testing done, then you finally move to the production. So that's all you have all these processes as part of the release process. Then the CI, where does that fit in? So CI comprises of 2 stages, the source and the build. So whenever you check in a code, and then you are ready, you have done a peer review, you're ready for the next process. The whole, from checking in the code to the producing of the artifact is continuous integration. So you check in code and it integrates and builds and it produces artifacts. Delivery. So even if you're deploying to a test environment, it's a delivery, or then you are deploying to production, it's a delivery. So you're deploying a delivery. So continuous delivery is when you're checking the code, it producing an artifact, and then finally you have your code ready for deployment. Then you test it in your test environment and you deploy it to production. So that's comes under the continuous delivery part. And then there is the continuous deployment part, which is ultimate goal for any team, where it is from end to end. But it is very difficult to achieve this goal, because it needs a lot of testing, a lot of confidence within the team that whatever you're checking in, whatever code you are checking, it has been tested thoroughly within the pipeline itself, so that it is ready for a production. Continuous delivery part also include a gatekeeper. So it could be a process, it could be a manual check, it could be it could be some sort of release management board or something, which will ensure that anything which is going to production is what it is meant for, and it has gone through the whole testing cycle, and it is ready for production. It is that's the ultimate goal. So but with the continuous deployment, it is really difficult to achieve that part as well, and you have to be really confident in your code, in your whole process, that whatever you're checking in is going to production. So but it's an ultimate goal for any team to achieve. Next is the AWS services. So code commit, build, deploy. Where does that comes in? So code commit is your source. So like GitLab, it's like that. A source repository where you check in your code and then you use it for peer review, and everything whatever you can do there, you can do here as well. CodeBuild. CodeBuild is another tool for building the code. So the build part where we are compiling the code, we are doing some sort of syntax checking using some tool, or we are doing we are producing an artifact, we are running a unit test. All you can do here, and how we do it, we write a build spec file, and then that's a configuration file. And then you write all the code, not exactly code, but you write some commands there, and then based on that it works. So we will discuss that in detail when we go to the demo of the code build. And the deployment part, the next part is code deploy. So you do a deployment through the code deploy. So there would be different hooks which you can use, and then based on those hooks the application will work. Application get deployed. So your artifact is get ready after the end of the code build, and then you use those artifacts to deploy the code to the environment, or EC2 instance, or ECS, or a Lambda, anywhere, and then you deploy that code using CodeDeploy. And the code pipeline is the integration of all these bits. So it's sort of wrapper, or it's a pipeline which will have a code commit stage, a build stage, and a code deploy stage. And when you run a pipeline, it will check out the code from the code commit, and then do a code build, and then finally deploy to environment using code deploy. So that's pretty much it, where this all fits in. And then we will go through the code build demo in detail just in the next slide. In continuous integration / code build part, we'll look into what app we are deploying. We'll create a new code build project, and we'll understand the build spec part, which is a file which will have all the commands which will basically define what code build will do, and then we'll run a code build project, a build. As part of different stages in continuous integration, at every place it could be different, but for our project we'll do a code checkout. We won't do a compile or style checker or unit test because it's a Python code, so we don't need to compile it. But you can obviously add some unit test if you wanted to see. We have a very basic hello world application, so we don't need it. We'll do a Docker build image. We won't do a scan. If you want, you can do it. In most of the places in production environment, in real scenarios, we definitely do the scan just to see vulnerability in the image. And then we will push it to a Docker Hub. So this is pretty much it we're going to do. In terms of application, we have a very simple application. A Flask app, I use this app all the time in other demos. If you have seen, this is just a hello world application which will just print a hello world. What we're going to do is we're going to build a Docker image. We'll use Python 3.12. And the requirement file, because it's a Flask application, we'll just use a Flask installation, and then we'll expose this on 500 and run it as a Python app. So that's pretty much it. And then we'll look into the build spec file. So that's the code part. We'll not use this build spec. We'll create our own build spec file. But yeah, we'll look into this. So we'll quickly create a code build project. So we name it demo app. Source. So we won't use any additional setting for now. We'll just leave default. For the source, we can use S3 AWS code commit, or any other, you know, Git supported source repositories. So we'll use GitHub because my code is in the GitHub. For connecting GitHub, if it's a public repository, you can actually mention the public repository name. But if it's your personal account, you can actually connect it with the GitHub. So my account is connected to the GitHub using OAuth, but you can disconnect it. I mean, I can actually show you. So let's connect with GitHub, and what happens is it asks you to confirm using OAuth, and you confirm it, and then it get connected with your GitHub repository, and then you select your CodePipeline demo. Okay, source version. Source version is you can actually define few things here. You can define your branch. You can mention here your commit ID, any tags if there is any tags you have defined, you know, or you know. So you can actually read about it as well here in the information. So you can do your commit IDs. You can do branch name. You know, you can do your pull request based on your based on your commit ID. So you can do many things, but we will leave as it is, which will take the latest. We won't go into additional configuration details for the webhook. So this is also important part. So if you so we say if you want it to be a continuous, you know, when you push a code, it should rebuild. It should rebuild on every push, and then you can actually select the event. So you can do so it says rebuild every time a code change is pushed into the repository. So you can do that, and you can even select the event, right? You know, when the pushes happen, or you want to do it on a merge, or you know, on a pull request. So for now we don't have pull request, and we are not doing a pull request now. We just leave it with the push. You can also select some conditions if you want, but this I won't go in details here. Environments. So you can select on-demand environments, or you can select from your reserve capacity. If you suppose have a reserve capacity, you can select it from there, or you can leave on-demand. Environments. You can select your the AWS CodeBuild manage environments, or you can select your custom image. Like, you know, if you have, you know, custom EC2s which you wanted to use, you can use those, or you can use, you know, AWS CodeBuild. You can also use lambdas these days. You can define, you know, you can use lambda for this, but I guess there is some restriction which how you can use it. And you know, obviously EC2s can be used. Operating system, it supports Windows 19 and 22, and Ubuntu and Linux. Amazon Linux, I'll use Amazon Linux. Runtime, we'll just leave a standard. Image, we'll use the latest 5.0, or we use the latest runtime image. Okay. Use GPU enhanced compute. We don't need it because we are not doing any image processing or any high GPU based processing, so we don't need it. Service accounts, service roles. So so I guess we can either create our own service role, or we can, you know, we can use the existing service roles if we have already defined, or we can create a new service role here. So we'll just leave as it is, and we'll create a new service role. What we're going as part of this, we are going to build this, and it will fail. I'll tell you why later in the video. You see, it will fail at some point because it doesn't have enough permission in this role, and we'll add that permission later. But for now, we just leave it as default, and it will create that role with some permissions. Any additional settings, so you can have your own additional settings as well. Any timeout define, you know, you can define the timeout of your build, you know, how many hours you want it to be, you know, to continue. Are there any long running builds, or you can define the long timeouts. It has a default of 1 hour, but you can define your own timeouts. Queue timeout, how long suppose you have defined a capacity and then other builds are in the queue, how long this build should remain in the queue to get the machine to get built. If you want to install any certificates, if you want, okay, so this is also one of the things. If you want to run this this pipeline within your VPC, because of some security restrictions, you can't run it outside your VPC. You can select your own VPC, and then this code pipeline will run within your VPC. Compute, how much compute you want to. Its default is 3 GB and 2 CPUs. But I guess you can increase based on your build capacity, based on your cost, if you whatever you want, and based on how much you want to give it to your build. Any environment variables you want to give it to your builds, and any file paths. So I'll just leave default for now. Additional settings, build spec, very important part. I guess we'll add this build spec now. I'll just cover the rest of the things and then I'll come back to the build spec. Any artifacts. So if it is producing any artifacts and you want to store those artifacts to S3, you can select S3. We are not producing any artifacts, we're just producing an image, a Docker image, and which we will push it to the Docker Hub. Any CloudWatch events, your logs, your build logs are being produced, so you wanted to push it to CloudWatch, because then you can refer it later as well. If your build fails and you wanted to refer it, you can refer it, or optionally you can also store it in S3 because of the same reason. Because suppose it remains for a specific period, then you can actually store in in one of the buckets for your cloud logs for your reference. So there are many options. We just not use S3 for now. We just leave as it is default, and it will create a group name optional itself. Back to build spec. So let's create this build first without build spec first, and then we'll come back to this build spec part. Let's see if it works. Okay, so we have this demo Python app, but it doesn't have anything. Basically it doesn't know what to do. So it's just a configuration shell, but it doesn't know what to do. So how we will tell it what to do is from this build spec file. And what we have left it defined default. So we said use build spec file. And so it will always expect a build spec file at the root of your project. So this build spec file is at the root of the project. So we'll leave as it is for now. But yeah, I guess what we're going to do is we will build this build spec file. Okay, so we'll switch it to editor and look at this file. It has it is a YAML file, and it has a lot of places where we can make changes and we can tell this build what to do. So it has environment variables, it has some batch if you want to run, it has some stages, the phase you call, what you want to do. So if you need something to install, you can do install. If you want to run some commands just before the build, you can run those commands. Any commands you want to run during the build, you can run those commands. Any post build steps, any report you want to generate, any artifacts location. So if your build is producing some artifacts, you can store them at some locations. So there are a lot of things which you can do, but let's quickly look into what we're going to do here. So as we discussed before, we are going to build a Docker file and then push image to a Docker Hub registry. But before that, we need a Python, because our app is a Python app. So we need a Python installation, and then we'll install the dependencies for the Python, so which is Flask in our case. So let's quickly do install. So what we're going to do, we need a runtime, okay, and the runtime which we need is Python, and the version is 3.12. Okay, so we install what we need. Okay, okay. Any command we want to run? Just before that? No, just leave it as we don't need that. Any pre-build commands? So yes, we wanted to install our requirement file. So so what does our requirement file has? So we looked at before. So our requirement file has a Flask application. So what we're going to do is we will say, and the command we want to run is because once install Python we will have pip. So pip install, and the name of the file which has this requirement is requirement.txt. Okay, so now what it should do is it should install our requirement. Sorry, I missed -r. That's the command. So pip install -r requirements.txt. So that's our command. So what it will do, it will install Python, and then it will install the requirement file, which is a Flask application. Because our application is Flask, so it will install Flask. So what's the next command we want to do? So because we are running this build, what we are doing in this build, we are building a Docker image, and after Docker image we want to push this image. So what the command should look like? So Docker, it should be a Docker build and a Docker push, right? So, and if you want to run some test around it, you can run some test, the stages which we discussed before. You wanted to do, unit testing, any sort of checking in terms of your code check, or, if you want to run some external softwares, you can. So it's all command based. You can run any sort of commands, during the builds. So yeah, so let's see what we're going to do. So how a command should look like. So it should, we'll go in detail, but I think we need to log into Docker registry first. So something like Docker login, and the next command should look like Docker build, and there can be another one, Docker push. Next push. Okay, so something like that. So so what command do we need? So we need a Docker login command. So Docker login command should be let's also write let's say, I'll just copy paste this command from my other window. So Docker login command will look something like this. So what it's doing, so it's just it's a login with the password. So what you're doing is you're getting a password, and then based on the password you are logging in with Docker. So it's a standard command. So Docker login. So it's a standard command, so which you use all the time. Yeah, so with the password, and you get it from whatever file is. So for now, in our case, what we're going to do is we want to get, because this is sort of secret. So what we want is any password we want to store in SSM. So system manager. So what we are going to do is we will store those, and then I'll walk you through about this. And then a Docker push, Docker build command should look like something. So Docker build -t, and you need to tag this, right? So what do you want to tag it? So your registry name, a full path, and a username to log in, and then your basically and your image name. So if you see Docker, so it should look something like this, this URL, Docker Hub URL, not exactly this, but and then tech with alloc is the username and the name of your image. So okay, so go back in here. So what it should be, so we have so this, if you see, these all are uppercase and with $sign, these are variables. We're going to define these variables in up per section in environment variables, but just give us a minute. We'll just understand everything. So what we need a Docker URL, so, and then registry name. I'll just copy this because I've written this in here. So okay, and name of the image. So we'll keep image name is CodePipeline demo. Yeah, and we have to give the version, so we'll just keep it latest. So now Docker build is URL, registry, username, and name of the image. Okay, and then we do a Docker push. So we have already logged in, and if we do a Docker push, it should push it, but it need a path, right? So again basically the same path. So exactly same path, Docker push, and so we have already logged in and the same path. So we have this. Okay, and write some echoes as well, just for our okay. So and in the post we can say the build is completed, something like that. So we do again echo. Okay, and do we need any sort of report? No, just leave as it is. Okay, so any artifacts? Yeah, I mean we'll leave as it is for now. We just comment it for now. Okay, back to these variables. So how these variables are defined. So let's log into our system manager, and in our case we are storing it in a parameter store, but it does support secret manager as well. So you can store your variables here, which are being used as a configuration, but if it's a secret, you should store it in a secret manager. But for our demo, we'll just store it here. We have this Docker cred password, username, and URL, which we are going to use in those variables. You can create your own secret parameter store, like so this naming convention, it's a good practice to use a path when in the real environments you have multiple applications and you're having hundreds of parameters. It would be a difficult thing to manage if you create those parameters and you don't have application names or some sort of your naming convention defined. So we are defining it as docker-cred, or if you have some application, you can define with the application name, or it's just a way of defining what these parameters mean and to which application these parameters belongs to. So you don't it doesn't become confusing at some point when there are a lot of parameters that what these parameters are for. So you can define it as a string, a list, or a secure string. You can actually secure it with a KMS key, but for demo's sake we can define it just as a text. So we'll leave as it is for now, and we have all these defined already. So we're going to use it in our build spec file. So so it supports parameter store, secret manager, it's some exported variables as well. So we don't need all of this. We are going to focus on parameter store, but the way to use this as a parameter store or secret is same. So what we need is we'll use it as a environment variable and as a parameter store, and we need some key and a value. So we need one more actually. So we need a Docker URL, a username, and a password. So what we do is we just need let's see what parameters are there. So we have these variables which we will use and define there in the environment variable, and as a value we will take it from the parameter store. Just password here, username here, and the URL here. So we don't need $, and the value will come from parameter store. So password, username, and URL. Okay, so we don't need batch processing. We are not doing any sort of batch processing. We'll just get rid of it. So we have this looks fine, I guess. So we have environment variables, we have runtime, installing Python, and then taking these variables, logging into Docker, and then building the image and pushing the image, and then we're saying build is complete, and then we'll see this image in our Docker Hub registry. So we are not producing any artifacts. We don't need this. We actually get rid of this. Okay, so update this build spec. Okay, give me a moment. I think it's my system time. So I fixed my system time, and let's update it again. Okay, so this is saved. So we have this build spec here. Let's quickly run this build. It sometimes takes a little longer to start the build, so but we'll wait for just a minute and see if it starts the build. Okay, it already failed. If you see the status, and let's find out. It will show the build logs in a moment. Why it failed? We have left one issue before, which is some permission issue, which I was talking about before. But let's see if it failed because of that or some other reason. So build log shows access denied, SSM permission. Okay, so it has failed because our role, which we have defined as part of this build, doesn't have permission to the parameter store. So this was the thing I was talking about before. So let's go back and see what is our what is the name of our role. So our role name is this. Let's open in a new tab, and it has opened this role in IAM. So let's quickly add this permission. So create a new inline policy. And then the service which you're talking about is system manager. And then what action we need. So let's take it from there. So build history. So it need a get parameters permission. So go back in here and say I need to get the parameter permission. This permission I need, and then next. Okay, so what resource I need? So you can define a resource just a specific resource with even a specific parameter. So we can define up to, Docker cred star, something like that. But for the demo, we'll just leave as it is. But you can actually define to a very low level, which will help to keep the security on. So we have this policy now, create policy, and we define this policy name as SSM permission policy. You can name as whatever you like, and this policy is here. And once it is here, let's quickly run this build again. So if you see, it has passed a stage where it was failing, and now if you see, it has starting come on our installation. So it is installing our Python 3.12. It is installing dependencies, so it did a pip install the requirement file, and then it's picking up the Flask application, and after that it started running Docker image, picked up this Docker login thing, and login was succeed, and then a simple Flask application latest. Okay. Okay, so this is fine, but somehow my feel is it hasn't taken our because if you see, the name of the application is taking something else, simple Flask application, but the name of the application which we defined, sorry, the name of the application which we defined earlier is this. Let's change it. Let's see if it is taking our parameter. So this is succeed. Let's quickly change the name of the application which we're defining, and let's say this is our CodePipeline demo. So we want to build something with this name and the same name. I want to build the image. Okay, so the build spec, and let's run this build again. Okay, so it is build is running, and it has picked up the name of our name of our image, and this is building that image, Docker build. And once it is okay, so it is finished. So this is what we have defined in our Docker file. So requirement.txt, it is doing a pip install inside this image, and it has finished. And now it's doing a Docker push, CodePipeline demo, and it is finished. The build is succeeded. So let's look into our Docker Hub if we can find a new image with a name called CodePipeline demo, and with the latest, so pushed just a minute ago. Okay, so this concludes our the code build part. So we'll start with creating an application. So we can name our application as sorry. So this is where you're going to deploy this application. Either you're going to deploy on EC2s, or you're using serverless lambdas, or you're deploying to ECS clusters. So we'll use EC2s, and we'll just create an application. Okay, great. So we'll try again after fixing the system time. Okay, so we are able to create a new deployment app. What we need is a machine now, EC2 instance, where we can actually deploy. So I'll quickly create a new EC2 instance, and let's call it will use Amazon Linux 2 for now and go ahead with the default settings. Key pair name, we already have a key pair. Security group, I need so let's enable SSH from anywhere for now. I don't need anything else for now. We just leave settings default, and because we wanted to launch this machine in a public segment, you'll just see the network settings, assign public IP enabled. So I just need this because I need a public IP to connect to this machine. For your use case, it may be we wanted to host this machine into your own VPCs in a private subnets, but for the demo, just so that we can easily access this machine, we're just going to launch it in a public subnet for now. Okay, quickly launch this machine and see what do we need. So let's see when this machine is coming up. We also needed a tag on this machine. So if you see the name and if you see the tags, there's a call name app server. Okay, because we need this tag to be able to identify this machine when we deploy. The code deploy should be able to identify where to deploy, and that happens based on the tags on EC2 machines. Okay, so let's see if it is coming up. Quickly, it's still pending. It's running now. So once we have this machine up and running, let's connect to these machines. So we'll connect it using this client. So let's connect this. This machine. So this. Okay. What is it? Permission denied. Because come to this machine. Set to go to domain. Touch mode. Set to. Okay, so I'm able to connect this machine using so my PAM file was in a different folder, so I logged in, I moved to that folder and then tried using the same command, and I am able to log in. So let's see what's there on this machine. Where am I? Okay, so I'm at the root folder. So now what we need to do is quickly install CodeDeploy agent. So we can look into documentation of there is a agent. So install CodeDeploy agent, and we can see there is a good documentation available. Install CodeDeploy agent using command line, and I'm using Amazon Linux. So what I've done is I've just copied everything into a separate file, and I'll just copy all these commands in one go. So you can just use the similar sort of commands. I'll quickly walk it through as well. So it's doing update first and doing installation of Ruby, and then installing wget. We don't need this because saying if there is a previous installation of CodeDeploy, just to clean it up, we have a fresh machine, so we don't need this. Then go to the home directory and then download and install the latest package for CodeDeploy from this specific URL. And you need to change the bucket name and the region specifier based on your region, and based on your region and the bucket name, and you can get the information on the bucket is from here. So my region is US East, so I need to use the bucket name as this, and region identifier is this. So I'll update my URL as CodeDeploy US East 1, US East 1 that. And then I will just give permission to the install folder, whatever is being downloaded, and then install it from the install folder. And then check my service if it's running, up and running. So I quickly copy paste all of this. Let's see if it works. Okay, let's see. Yeah, use this installation Ruby, and then we complete. Installing is CodeDeploy agent is downloaded, and then installing on the CodeDeploy agent, and then I check the service and it says started. Yep. Okay, cool. So it looks fine. Okay, so so we have this agent running. We will check the status again just one more time. And the agent is started. Okay, so looks fine. Then we have an agent. Now we have EC2 instance. We need two rows. One is to access CodeDeploy from EC2 instance, and another is from CodeDeploy to be able to talk to EC2 instance to be able to deploy the application. So or we can use a single role for both the purposes. So that's what we're going to do. We're going to create a new one role, and then just so we'll create EC2 use case. And then we can, other services is CodeDeploy we need, right? So we need CodeDeploy. Yeah. So we need this row. Next, can we name it as demo EC2 CodeDeploy row. Okay. Yeah. So this will allow, this is trust policy, and this will allow CodeDeploy access, but we need another trust. Is so that EC2 can also talk to it, right? So just need another trust. So we need another one. There is EC2. Next, and then we need EC2 full access or something. For now, I mean, you can select a specific permission, but for now we'll just give full access as well. So okay, so it has CodeDeploy and EC2 full access, and create a row. Okay, so you should have a role, and then let's quickly assign it to security. Just needs machine security modifying role, and we should be able to see this demo EC2. So now this machine should be able to talk to CodeDeploy. So we need what so looking at the trust policy, at the moment if you see a trust policy, it says EC2 Amazon.com. so it basically means can only talk to, it's only for EC2s, so it has a permission for only EC2s. So what we're going to do is we'll make a minor amendment and we'll add another trust for it and say we need this for CodeDeploy as well. So let's quickly update this. So we need this. So this basically says a trust the CodeDeploy and EC2. So this rule can be used at both the places. I'll just quickly update this policy, and we have permission for both. So EC2 full access, so CodeDeploy can access EC2, and AWS CodeDeploy, so that EC2 instance can access CodeDeploy. Cool. So now our role seems fine, and we have already assigned it to EC2 instance. So let's head back to our application. So we were able to create an application, and now we want now CodeDeploy to be able to deploy to EC2 instance. So we will create a deployment group and select where it should be able to deploy. So we'll name demo DG for now. Service role. Okay, so now we have the service role, and this is coming from both. So because it has permission to be able to talk to EC2. Choose how to deploy your application. Update instance and deployment group. Latest applications, yes. Blue green, we are not doing it at the moment, but we can choose blue green deployments as well. Environments. So we are just using an EC2 instance without an auto scaling group. So we select this, and there are no on-premises instance at the moment. So and the key. So we select the name, and as soon as you do this, it says there is a one unique match for the instance, which is the key to this whole thing. How CodeDeploy will know where to deploy, what instance it should pick up. So the tags are the key. So you select the right key, right tags, and then it will pick the right instances. It could be more than one instances, it could be one instance, so it will select the right instances. We don't need to install a CodeDeploy because we have already done, so we don't need to do it. For now, we'll just leave it never, and leave the default settings. CodeDeploy at once, all at one time. So these are the settings which says, for canary deployment, where you deploy some of the stuff, or blue-green deployments where you send some on the new, some on the old. But we're not doing this. We are just deploying everything at once, and we don't need a load balancer. So we don't need any advanced settings. We're not going for any advanced settings as well. So let's create a deployment group. Okay, so we have a deployment group as well. Now let's create a deployment. So we have this deployment group. We'll select our GitHub repository. For GitHub token name, so this get assigned. So you basically can create your own token and then get a permission from GitHub, your own GitHub, and then assign that permission to the token. And then you can use that token to reference your own GitHub repository. If you want, we can have a separate video on that one. Repository name. So we're going to take the repository name. So we don't need a github.com. So we just need the main repository name and the commit ID. So we'll use just the last commit ID. Okay, and we will leave everything as default. So before we create a deployment, let's quickly look into what we're trying to do. So it has separate it will run this hooks, different hooks, and it looks for appspack.yaml file, and we have that appspack.yaml file in the root location, root of the folder, the code. So this looks, this file has several hooks. You know, we will use just 2 for now, but there are few you can use, and there's a good documentation in AWS for this one. So we will use just an application stop and start, and we will use 2 scripts for it. So application stop, if there are any previous containers, we'll stop all the previous containers, and in the start, we will start our new container. We will download the image, whatever we have uploaded as a part of CodeBuild, and then we will start the containers using the Docker. So just quickly look into it. In the start, we are just logging into the root, and then we are downloading the image, and then we are just running the container. In the stop, because we don't have anything at the moment, so I'll just comment this code, but we will try this remove container as well. And if you see hooks, we are providing it as, you know, what user we are running it. It says run as root. So we are running as a root, so it will go in a root, but it doesn't have admin permission for the root. So we'll just log in root as an admin, and then we'll run the stop command. So let's quickly create this deployment and see. Okay, so I just created a deployment and it is in progress, and let's quickly take a look. Okay, it failed, and I know why it failed, but let's quickly see. So it says it doesn't have a Docker. So when we installed CodeDeploy agent on on the EC2 machine, we should have installed the Docker as well, because we are using our Docker, but we don't have that on the machine. So what commands we need, I have already added to the script. So we need these 2 commands to install the Docker on the machine. So we'll just quickly go jump on the machine and run these 2 commands. Okay, so let's see if we have a Docker. Yes. Okay, still doesn't like it, so let's see. Because I'm running, so my user doesn't have any permission, so I should run this. Okay, so it does run. So now the Docker is there, so I'll run this again, the same deployment. So retry the same deployment. Now hopefully we should have a green build. Green, let's see the events. So application stop, we are not doing anything. We have just commented everything. So these are the hooks which I was talking about: application stop, download bundle, before install, during the install, after install, application start, and a validation of the service. So we're just using 2, after install, and we're using application stop at the moment, but you can basically use all of them. This is just to give an idea what is. So now this works. Let's try another thing, which is our the stop container as well. So let's try this. So we will stop a container, and we'll see how it works. We just don't need help. Okay, let's see. We have agent running, so I'll just comment this. And we'll stop. So it's simply doing taking all the containers and stopping it and then removing it. Okay, so this should get pushed, and then we should have a new commit ID. Sorry, we should have a new commit ID. Yeah, so we'll just copy this And then what we're going to do is we'll create a new deployment from applications, demo group, and then here we'll create a new deployment. So what we'll do is we'll just copy an existing one. Copy deployment, and then it will have all the previous application and all the previous settings, and we'll just change the commit number, and that's it. Let's see if it stops and start. Let's see what just at the moment it is there. Oh, it has 2. Let's see. It failed. Okay, let's see what happened. So the failed program external connectivity points in this. Okay, maybe we were using this, so I'll just stop messing with this port already allocated. Oh, so because port is already allocated, but it should have picked up our let's see what happened in the previous stage. So what happened in our events? Application stop. Did it do anything? Just in 1 second. Fail root user. Okay, let's quickly delete this deployment and then create it from the scratch, because sometimes it takes from the cache as well. Port is already allocated, because what it is complaining about is because this port is already there, so it hasn't stopped. It doesn't stop the container. But what we are looking for is stopping the container. So let's quickly see and create a new deployment. Actually, let's go to application deployment group and let's create a new deployment. Take from here, post rename. Just use this. And the commit ID I'm after is this one. Let's see, because I have seen a couple of times it takes it takes something from the cache. Let's quickly see what's happening. It has gone past the application stop. Seems it's taking a little longer. So I'm assuming it's actually stopping a container, and it is probably trying to do okay, so yes, so basically it was taken from the cache. It hasn't picked up our change. So yes, what it did is it stopped. It took a little longer, but it stopped the container first, removed the endpoint, and then it downloaded our image and then installed it. So that's pretty much it for this part. And then let's move to the next part, which is application code pipeline. So we will connect all the dots and then we'll make it as a part of the code pipeline, and which will run from CodeBuild to the CodeDeploy. Let's create a new pipeline. Name it as pipeline. We keep pipeline type of version 2. We can create a new service role. We already have existing service role as well, but we can keep our name whatever we like. We can type basically it will create the service role. We are not going into any advanced settings. We'll just keep as it is for now. It will have a bucket for S3, just keeping our artifacts. We'll just leave as it is. Next. So it says name exists. Let's use the existing one. And then next, source provider. So that's the important bit. So we select the GitHub version 2. And the connection, so you can create your own GitHub connection. You can connect to GitHub, and so you can type your connection name. I have this GitOps contact, you can connect. Yeah, it's connecting, and it asks you any application you want to install. I've already installed the application, but you can install your own application. I have this already. You can get the password, and after password you can actually get the permission, but I guess I don't need it for now. So I've already installed it, so it doesn't matter for me. So just fine as it is. I'll choose the connection, but in your case you will have to assign it there in a GitHub. The name of the repository, so we choose the name of the repository, so just the name and the repo name. Copy this. We'll keep the trigger as push in the branch, so any changes made in the branch would trigger this pipeline. We only have one branch, so I'll just keep that one, the main, and leave everything else default. Provider code. So we have already used CodeBuild as our build provider. We're not using Jenkins. We have an app defined already. Just use a single build to default, and our deployment provider. So that's our CodeDeploy. We already have an app defined, which we have defined previously in the demo, and a deployment group, and then we do next, and that's pretty much it. We create a pipeline, and as soon as we create a pipeline, it should trigger a build, which will pull latest from the source, and then it should do a code build, and it should do a code deploy. Let's see how it works. Okay, so source checkout is fine. It is able to, and now it is doing a code build. We can actually take a look in the detail here. So complete. I'll just finish, and it's still showing any progress. But hopefully this should complete within this minute or so. Yeah, this is complete. And yeah, and let's succeed. And then it's going a code deploy. We can quickly look into the code deploy as well, what it's doing. It has gone. It has already succeeded actually. So all the stages in the code deploy succeeded. So this is this proves that the pipeline is just a wrapper over build and the deploy, and it does work more beautifully with CodePipeline. Is all stuff. So yeah, that's pretty much for our demo. If you like it, please share with your friends. Please subscribe to the channel. It's really helped us. And thanks for watching.